So who would like to share a contextual situation where 3 equals r times 4? Yeah?
3 equals r times 4 can mean that you get a certain amount of money for 4 hoops you make. You end up with $3.
So you get a certain amount of money for how many baskets you make? Okay. So how much would that money be? 75 cents, right? So for every basket, you get 75 cents. 4 baskets, $3. Okay. Someone else, another contextual situation? A real life situation that you wrote down? What's yours, Austin?
What?
Your contextual situation?
Cost. It'd be cost for like teddy bear.
Oh, you must be in a very loving mood today. So, how much is each teddy bear? It'd be the rate, which is how much?
50 cents.
Nope.
75.
75. 4 teddy bears cost $3. Cheapest teddy bears ever. Mateus.
I said that if you bought Reese's, like 3 Reese's for 75 cents, it'd equal $2.
Right. So 75 cents per candy. I buy 4 candies, cost $3. Anyone have like a different one? Okay. It also could mean this. It could mean your team plays 4 quarters of football. They score 0.75 points each quarter. They score 3 points in the entire game. AKA Patriots defense. It could mean a Los Angeles Rams fan. But that could be quarters and that could be total points in an entire game.
Yeah.
So over 8 quarters, they would score 6 points. That'd be 2 full football games. That's if they were playing the Patriots again. So just want to make sure we're clear on that. Okay. Read pages 54, 55, and 56. You need to write down, I'm going to give you about 2 more minutes. Write down one important idea and make sure you explain why you believe it's important from that reading. Okay, I'm going to give you 2 more minutes. Like the kids that are restating the question, one important idea that I read is okay, what I'd like you to do, at your tables, share about what you read and one important idea that you're taking away from that. We have about 30 seconds. Go.
It is important that the you contain to answer the second one.
Numerous solutions, right? That's kind of what they were talking about. Lots of different solutions. All right, so great work on the partner test. This class, you guys did really well. Super pleased. Average in here was like around an 84. It's really good. Fantastic job with the Socratic Seminar. I really enjoyed that, and we're going to work on that just a little bit right now. So what I'd like you to do, and we'll get to this in a minute, I'd like you to take out your Socratic Seminar paper from Thursday. So put away your warm-up. You can finish that later. Grab your seminar paper. Okay, you are going to, we're going to get together with our toolkit partners. Okay, so whoever has the same color toolkit as you do. And the idea is I want you to have a discussion around the
girls' basketball team. They travel today to Canyon.
That's Addie.
Good luck, girls.
Good luck, Addie. Addie's it's going to be 5v1.
We'll see.
You're going to take them on all by yourself. So, thank you, Otis. So, I want you to have a discussion with your partner, your toolkit color partner, around the questions. Okay, what was different? What was same? Okay, follow the, so please stand up. Go find your partner, toolkit partner.
This one?
And you might have, yep. Who's got pink? Eli.
No one else does like.
Yeah. Dylan does.
Oh, there's three.
Who's your toolkit partner? You're over here. You're with Jayla. Austin is not orange. Austin, who's your partner?
No, I don't know.
Well, go find them.
What if there's nobody that is the same color too?
That's that. What? Oh, that's here. What are you, green? Who's dark blue? I know I have a dark blue back there. What color are you, Schmitty? Purple? Purple. Dark blue. Taya, what color are you? What? Yellow. Austin, come on, get with these guys. Okay, start talking about your questions. What color are you guys?
Pink.
Black. Light blue.
Wait, which?
Because who? Go with them.
I don't have the picture.
Come on.
I don't have it, so I'm just gonna look.
One interesting idea that
I just want to go over our notes for the first question. I got that a graph is easier to use. That did not match my thought. The idea that matched my thought was that a table is easier to use.
So what was the idea that didn't match your thought?
That a graph is easier to use.
Explain why to the group.
Ready?
I was confused about which question was which. The 31A, was that the one with the... Which one was which? I don't know which one was which. Though, was Allie and Grace the 31A, or was that the other one?
That's number one.
Oh, so that's question one. Oh, that's good. So I thought it was... we're supposed to be sharing this, right?
Yeah.
Okay, so I thought it would, I agreed with Dylan, it was easier to use a table for that.
The idea of the graph because you can't really put it.
What are you guys on? Which one? Okay.
Shared that did not match my thought was just the thought that the X and Y can be a mistake.
And that's something you disagreed with?
I get really confused with equations sometimes. I do too.
What part of the equation do you get confused with?
Well, I'm not sure. I just feel like it would just confuse me. Like it does kind of confuse me. I find it hard to use graphs.
Okay.
Well, I couldn't work with an equation. I'm just not very good at creating equations to use because they end up not making any sense at all.
You are pretty good at it.
And then my dad would come behind me and go, that doesn't make sense. And then we'll correct it.
Okay, let's come back together here. Okay, some of the takeaways from the Socratic Seminar. What were some of the takeaways for you guys? There's no right answer here. Just looking for some feedback. Justin?
Can you elaborate on what you mean?
Yeah, like what were your thoughts around the Socratic Seminar?
I think it's an interesting way for learning, like putting people out of their comfort zone.
Did it put you out of your comfort zone some?
Definitely.
Okay. Good. Okay, so you're speaking from like personal experience. How did it kind of push you out of your comfort zone?
Talking in front of class.
Okay.
I mean, it's different, like saying what you think the answer is or something.
Yep.
Because you don't want to get something wrong and get embarrassed.
Okay. But did you feel that there was a right answer for each one of these?
Well, some of them were opinion-based, so for those, not necessarily. So, no.
Because I tried to create the questions that were more belief and perspective, right, than yes, right or wrong. It's like if you can defend it, and because of whatever prior experiences you might have, that might be totally applicable to how you perceive that question, which is why I kind of worded those questions that way. Any other thoughts about Dylan?
It was just a good way to talk to each other to get our ideas out.
Was there did any of you feel like Justin challenged, or was it too difficult, or who enjoyed it? So, okay, good. Well, that's really good to know. That we all kind of enjoyed the conversation. What made it interesting? You had your hand up there. What made it interesting, Peyton?
It was more interesting because I've just never seen something kind of that way, just kind of sitting and then talking. I mean, it confused me. I really couldn't understand what anyone was saying most of the time.
Interesting.
Because I wouldn't hear one person and someone else would start talking, I could hear them. So I'd hear parts of the conversation, but not all of it. And so that confused me.
Okay. What worked well? What worked well for Eva? What worked well for you or Tatiana?
I thought that we were really smooth and getting when one person ended the conversation and the other person started really quickly, so that it bounced across really smoothly.
You guys were super respectful. I thought you were. I thought a number of you tried to get other people's perspectives. I remember a couple people asked Austin, what are you thinking? It's really important that we gain perspective from others, especially people who are quiet. And that's, in our media world now, that's a very difficult thing. Quiet people don't get a platform. Even though their perspectives might be more worthwhile, right? And I think what you guys did is possibly recognize some of that. That even though someone might be silent and listening, doesn't mean that they don't have something amazing to offer. And sometimes it's pulling them into the conversation that's important. Eva, what were your thoughts?
I thought it was like a good way for everybody to just share their thoughts. And I don't know, everybody was pretty respectful and not judging other people for what they said.
Okay. Who revised their thinking during the seminar? 1, 2. How did you, either one of you want to share about how you revised your thoughts?
When people disagreed with me or either agreed with me, I revised my thinking to see
So you're kind of taking what other people say and you're like, wait a minute, maybe.
change it or not.
Right. You're like, oh, wait, maybe I need to change that piece of it. Sometimes you don't change your whole thought. You just change a small portion of it. Or your thought becomes more complete, right? You think of it like, oh yeah, I believe that. And then all of a sudden someone says something and you're like, oh, I didn't think of it that way. It doesn't change what I thought, but I'm going to revise it so now it's a more complete thought. So we'll definitely do it again. Did having the idea of you knew exactly what problems to work on and you knew now you know the structure, do you feel like that will help you be more successful next time? Because I thought we did really good for the first time. But next time I really want to make sure everybody has 2 chances to talk. All right. I just want to congratulate you on that because I've never done it in math. So that was I was kind of worried about how it was going to go. This is really neat. So a friend of mine who showed me Socratic Seminar 6 years ago, he really helped me learn Socratic Seminar. I had heard about it before and had seen it done, but not very good. He works at Aspen Academy. He has a Socratic Seminar guru. And he taught me so many things about it. On Thursday evening, he must have got the slide of Socratic energy from our math class because he literally wrote me Thursday night and was like, hey Scott, what's up? I know it's been a while, blah, blah, blah. I just published my new book and I'm going to send you my new book. And it's a Socratic Seminar book. And I haven't done a Socratic since leaving Aspen Academy. That's called connection. That's cool. All right. Put away your Socratic stuff. Head back to your seats. Please get your notes in front of you. I'm going to do a quick think aloud. So this is going to be a think aloud and show for you to give you some scaffolding. Now, based on hey guys, based on your test results, I know there's a couple pieces that I got to connect with. So you'll definitely see that. I'm going to hit on a couple pieces here. I'd like you to have this in front of you. We're talking about relating the coordinates of a point back to a table, an equation, or a graph. So, we know what coordinates are, x and y, so that those numbers mean something. Here, my x, what does it mean? Distance. And up here, it is my independent variable, or, and I'm just going to put in parentheses, my x variable. And you can take these notes. My y, which is going back to our learning target for the day. My y, I come over here, and it is amount earned, because we're talking about this walkathon. And that is my dependent variable. So that's shows up on the y-axis. So these points mean something in my equation. And what they are is they're actually a solution to my equation. And they're a solution to the graph, and they're a solution to the table. So if I have the point 3 and 6.5, I know that that's x, that's y. That 3 means something, and it means distance. So for every 3 kilometers, and this 6.5 means something, that's how much I make. So if I go 3 kilometers, I make $6.50. And there's that point right there on that number line. So how does that work in my equation? Well, I could do it either way. That's 0.5 times d. I could put x in, and that x is going to go into my independent variable d. So I go 3 times a half. Well, that equals 1.5. 1.5 plus 5 equals 6.5. So that's how I get those coordinates. If I know my independent, I can put it in. To d, I do the multiplication, I add the y-intercept, and I get my y value. So when I have $3, I have 6.5. I also could do this the other way. Instead of putting the independent value in, I could put the dependent value into my equation. So my independent value is 6.5. And I know that's going to equal 5 plus 0.5 times d. So this way is a little bit harder because I'm trying to figure out d, so I have to get rid of all this stuff and isolate d. So how do I get rid of a positive 5? Well, subtract 5. So if I subtract 5 from that side, I subtract 5 from this side, I get 1.5 equals 0.5 times d. How do I get rid of a 0.5 that's being multiplied? Divide by 0.5. That turns to 1. And I know that 1.5 divided by 0.5, d equals 3. So I can do it the other way as well. If I know my dependent value, I can put numbers in and figure out the independent. If I know the independent, I can put numbers in and figure out the dependent. So over here I have the question, does the point 30 and 20, head up please, 30 and 20 lie on the line? Well, I can use the equation a equals 5 plus 0.5 times d. I put 30 in for d because the d represents the independent value. So that would be a equals 5 plus 0.5 times 30. Well, 0.5 times 30 is 15. 15 plus 5, a equals 20. So yes, that point would be a solution to my equation here. there, and that is why that point is right there in the graph. So then the question is, does 20/20 lie there? Well, if 30/20 is on there, there's no way that if it's linear, that 20/20 is going to be on there. But I could check. I could put 20 in, 0.5. I put 20 in for D. 0.5 times 20 is 10. 10 plus 5 is. So 2015 is on the line. And that would make sense because I'm going from a greater X value to a smaller Y, and that's what I have here. But not 20/20. So how would I could figure out numbers that aren't on here. Like if I wanted to know, what about 200 kilometers? Let's say I do this walkathon and it's over the course of a month. And every day I go out and I walk like 5K. Austin, head up, please. Well, I'm going to get up to 200 kilometers. And then I'm going to have to collect all this money. So I wonder, if I have 200 kilometers, how does that work in here? Because what I'm saying is, if I know this, can I figure out why? Can I figure out how much money I'm going to make? Because I know that 200 is going to be on there somewhere. And then when I'm at 200, what's the Y? Well, I can take the 200, put it in for D. Half of 200 is 100, plus 5 is. So when I'm at 200 kilometers, I would make $105. All I'm doing is plugging in my independent value, doing the calculation, and getting my answer out. You will find that sometimes you're going to get this, and then sometimes you're going to get this. Let's say I wanted to earn $200. How far do I have to walk? That's a different question. So the 200, which is in the Y, goes in for A. And now I have to isolate D to figure out what my X value is. What's my independent value? What I'd like you to do, we're going to work about 8 minutes alone. So you are going to go to page, we're going to do some productive struggle. It's 3.1, 56 and 57. So you're going to start on A all.
Did you see Tom Brady kiss Belichick?
No.
Tom Brady kissed him on.
He also kisses Giselle too.
Yeah, I know.
I didn't see that. you stuck on?
I'm just rereading.
Okay. So in D is what? Because that's what I'm missing.
Distance?
Yes, but see, you're getting rid of the 5, but you got it. But that means you're trying to figure out A or D. Which one are you trying to figure out?
D.
So what's A worth? What's A's value? Right, because we know that we're talking about these coordinates have X and Y. So what you're doing is you're like, well, hey, I want to figure out what X and Y are. Which one do you know?
You know why.
So if you know Y, what's the value of it? Okay, so what's Y stand for in this equation?
Independently. Kilometers or distance.
Okay, that's your X value.
Oh,
So that means that your 23 would go in there. So that means I don't have to take 5 away because that's what I'm trying to find. It's already by itself. Does that make sense?
Not really.
Okay. So if the whole reason why sometimes I have to isolate the variable is if it's with a bunch of other numbers, but A's not. Right? The amount that I've earned isn't. So I can just put 23 in. 23 times that plus 5. What does that equal?
Oh, okay.
So what you want to do is you want to write the equation with 23 as your independent variable.
So does she make? So she makes $5 each form, or 5 cents.
No, not 5 cents.
$5.
50 cents.
Oh.
0.5.
Does she have $5?
Yeah, she has a $5 at the start.
I did that wrong. I was going like 5 cents.
That's a pretty small donation.
Yeah.
Okay, I'm going to give you 2 to 3 minutes to talk to a peer if you have questions about how to get started. If you don't, continue working independently. If you do, take the time right now to ask a good question to see if they can help jumpstart your thinking. So does that make sense?
Yes.
So that's how much they, yes.
Yeah, good luck trying to read my handwriting upside down.
No, this is really good though. You're actually writing neat enough so I can read it. Yeah, that's it. It's right, they don't even ask you for the value, huh? They're like, write the equation, and right, they don't even care that you know the value. So you're on A here. So it says, suppose she walks 23 kilometers. So you got kilometers, bingo, because that's the independent and value. Awesome. A table's one way to do it, right?
And then it also says graph.
Right. So show using a table, and then not. Let's just do table. Don't do the graph, and then move on to the equation. Just stop. Well, tell me about this equation. What is this equation? What does it mean? 0.5 mean? Do you know? No, A is that. That's the amount of money.
Oh,
Are you in some, can't talk with?
no, I was too scared to talk for a second.
Okay.
I was trying.
So this is the amount of money they've earned. This is the distance. So what's the 0.5?
How many kilometers?
Not exactly.
The rate it goes by.
The rate.
Yeah.
So she makes 50 cents
Mm-hmm.
for every kilometer. So you need to use this to help fill in your chart,
Mm-hmm.
your table. No, it's good work. Yeah, no, it's a good sketch. So you have, this doesn't mean days.
What does it mean? Distance?
So let's go back to distance and amount earned. So I don't know where you got this equation from. Because
Oh, that's what I got after doing.
okay, but they're asking you to use that equation.
Okay.
So you need to go back and fix that. And make sure when you fix it, think about which variable depends on the other, because the dependent variable should be the second one in your table, not the first. Wait, you multiplied it by 1.5.
Oh.
It's just 0.5. Come on, this is what we're talking about. I need you to work, not fidget. That's not going to help us get better at math.
I think I got 82.
Uh-huh.
Trying to figure out how many kilometers you have to walk to get $30.
So now you got, so there's that's the equation.
Yeah.
So that first question, because we're talking about coordinate points, and you guys just put your pencils down, look over here. It's basically saying, hey, if she walks 23 miles, how much money does she get? That's the question. And I know that this is kilometers, and that this is money because, if you look at the graph, that's the x-axis, that's the y-axis. And I know that here in my equation, D is my kilometers because money's dependent on that. So you guys did a great job. You're like, hey, put 23 in. That's my equation. This is how I'm going to figure out how much money I make when I walk 23 kilometers. The second part's different. It's saying, how far does she need to walk in order to make $30, right? Isn't that it? So this is different because now I'm not trying to find my dependent variable. I'm trying to find the independent. So now my equation looks like this. 30 equals 5 plus 0.5 times D. This is harder to figure out. How do I do this? Because it says, hey, if I want to make $30, how far do I need to walk? Someone tell me how to do this? How do I isolate the D all by itself? Connor? I would, but not right off. Here, I'm adding 5. What could I do to get rid of a plus 5? Subtract 5. Subtract 5, right? Got to do it on both sides. So now I have 25 equals 0.5 times D. Now, how do I get rid of a 0.5 that's being multiplied? Divide by 0.5. That turns to 1. Divide by 0.5. 25 divided by a half. D equals. So how far do I need to walk if I want to make $30? I have to walk 50 kilometers. So now that this is actually the coordinate point. That's one solution, Mateus. That's one solution. But it all started off not knowing the x value, the independent variable. Okay, go ahead. Put this in your learning tab. Okay. As you're putting away, please look up here. Homework is 1A, B, C, D. So Jayla's getting out her planner, Dylan's getting his out. 1A, 1B, 1C, 1D. On page 69. This is already on the classroom, so if you forget to write it down, you can go and find it. 1A, B, C, D, page 69. Okay. So, if you guys could look over here. These axes aren't labeled. It's just X and Y. So I'm just going to label this distance. And I'm going to label this money. So that's your job. Over here I've got all these points. Distance, money. Distance, money. Your job is to tell me, does this point where I walk 3 kilometers and make $11, is that on the red equation or the blue equation? And then you're going to do it for 5:17, 5:14, 10:32, and 12:28. You got 4 minutes. You're going to need all that time. Here's the equation for red. Here's the equation for blue. So on your paper, you just want red, blue, the equation, and then list the points. Connor, 3 and 11. When I walk 3 kilometers and I earn $11, which line does it represent? The red one or the blue one? The red one. Now I could use the graph, right? Boom, boom, find it. I also could use the equation. 3, put in for the independent variable. 3 times 3, 9. 9 plus 2, 11. That means that belongs there. So down here I would write 3 and 11. That point is on that line. Payne, what about 5 and 17? Red line, blue line.
Red.
She says red. Well, again, I could come to my graph and find it, or I could take 5, put it in for x, because that is the x value. 5 times 3 is 15, plus 2, 17. So 5 and 17 is also on that line. Well, Eli, what makes 10 and 32 more difficult than the other two that we've already done? It's not on the graph, right? Because it's not on the graph, what do I have to use? I have to use the equation in this example. So if I went to 10 and 32, I put 10 in here. 10 times 3, 30 plus 2, 32. 10 and 32 is also on the red. What about 5 and 14? I put 5 in here. What's 5 times 3? 15 plus 2, 17. That is not on the red. 5 times 2 is 10 plus 4, 14. So 5 and 14 is over here in the blue. So that leaves you with just 12 and 28 and 50 and 104. If you're done, you can put away your things. If you're not done, remember, you need all 6. They got to be either in the red or the blue. That will be worth at least 4 points on the grading this week. All right, guys, we'll see you later.